Hello and welcome to today's lesson on properties of figures. This is going to cover topics in the standard 5.2 in geometry, and then we're also going to go over questions in the study island lesson called properties of figures. To be successful with these lessons, you're definitely going to want to review your distance formula and then properties of triangles and quadrilaterals. So these are lessons that were covered in the standards 2.3 and 5.1 videos. So if you need to go back and review those real quick, please do so. And then you also can be taking notes as you go along. And then if I go too fast, just pause or rewind. And then you can also pause at the beginning of a question, work it out yourself, think about what you think the answer is, and then watch the video and check yourself. And that way you can get a gauge of how well you're understanding. So I'm so glad that you took the time to join us today, and let's go ahead and look at some problems.
This first question plots out some points and connects them in a quadrilateral, and it wants to know what is the most specific name for this. We have kite, rhombus, trapezoid, parallelogram. So looking at it, it's most likely the answer is going to be a kite. However, if you weren't sure, I want to show you how you could know for sure. And so we know a kite, we know that these two sides are congruent and these two sides are congruent. So we'd want to go ahead and find the coordinates and calculate the distance formula to see if those two pairs are actually congruent. So the coordinates of L are 2, 2. The coordinates of M are 3, -3. The coordinates of N are -2, -2. And the coordinates of K is -1, 1. And so first we're going to find the distance from K to L. So I went ahead and wrote the coordinates of K to L and then the distance formula also. So remember, it's always a good idea to label your coordinates X, Y, and X, Y so that you know, so you don't get your X and Y numbers confused, because that's the most common mistake in these problems. So first I'm going to substitute in my X value. So that's a -1 minus 2. That's squared plus my Y value subtracted. So that's 1 minus 2. That's squared. And so then I just simplify the distance formula. So here is -3 squared plus -1 squared. Then I square both those numbers, and that's the square root of 9 plus 1, which is equal to the square root of 10. So K to L is the square root of 10, and so now let's see if that's the same as the length of K to N. So I went ahead and wrote down the coordinates of K and N, and I'm just going to substitute that into my distance formula. But first I'm going to go ahead and label the points with the X and the Y so I don't get them confused. So I'm going to have -1 minus a -2, those are my X values, plus Y minus a -2, and those are my Y values. So when I do that subtraction, that's going to be a +1 squared plus 3 squared, which that equals the square root of 1 plus 9, which equals the square root of 10. So those two check out. They are, in fact, the same. They're both square roots of 10. So then I would want to check out the other two also. So I went ahead and wrote down the coordinates of N, M, and labeled them X and Y so I don't get my numbers confused. And I'm going to go ahead and subtract my X's, so it's going to be -2 minus 3, and that's squared. And then I'm going to subtract my Y's, just using that same area distance formula from before, minus a -3. And that's all squared. So when I go ahead and do that subtraction, that's going to be -5 squared plus 1 squared. And negative 5 squared is 25. And 1 squared is 1. So 25 plus 1 is 26. So the length of NM is the square root of 26. And then I want to check to make sure the length of MN is the same. So I went ahead and wrote down the coordinates for NM. And then I'm going to go ahead and substitute into the distance formula. So I'm going to subtract my x's. So it's going to be 3 minus a negative 2, that quantity squared, plus, and then subtract my y's, negative 3 minus a negative 2, that quantity squared. And then I'm going to go ahead and do that subtraction. So 3 minus a negative 2 is 5 squared, plus negative 3 minus a negative 2 is negative 1 squared. 5 squared is 25, and negative 1 squared is 1. 25 plus 1 is 26, so it's the square root of 26. And so they both check out to being the square root of 26, so it definitely is a kite, and that's letter A. Okay, this problem here, it's very similar to that first question, only they don't graph it for us, they just give us the coordinates. So what you're going to want to do is you're going to want to grab a piece of graph paper and plot those points and to get an idea of what kind of shape this is going to be. If you don't automatically get graph paper on the EOI, ask for it because you're supposed to have it. So you're going to have 2, 2, and then F, so that's letter E. And then you're going to have F, which is 7, 0, so that's right here. And then G is 2, negative 2, so that's right here. And then H is negative 3, 0, so that's right here. And then you're going to want to connect those into a quadrilateral. And I'm drawing as straight a lines as I can. You can always use the side of another paper, though, to do a better job. And so you're looking at that, and your choices are rhombus, trapezoid, rectangle, and square. Well, you can definitely look at it and know that the square and the rectangle, C and D, aren't the same. There's no right angles there, so it can't be that. And all those sides end up they look like they're going to be about the same. So your guess here is going to be A. So what you would have to do is you would have to do what we did on the first problem, and I don't have enough time to show it to you again, but you would take the coordinates E and F and calculate that distance. Then you would calculate the distance of F and G, and then G and H, and then E and H, and then all of those will work out to be the same, and then you know for sure that it's a rhombus. Okay, so this time it's a triangle. It's the same process, but they just give us 3 vertices. And they want to know what kind it is. Is it scalene, isosceles, or equilateral? And if it's scalene, is it acute or obtuse? So here, the numbers are kind of big to try to plot. I mean, you definitely still could if you had a big enough piece of graph paper, but in case that's not an option, I want to show you how you would do this. You'd have to find the length of each side. So you're going to have HI as the first length to have. So I'm going to go ahead and label all of these coordinates XY and XY and XY so that we don't get our X and Y numbers confused. And then I also wrote down the distance formula for us to refer to. So the first thing I'm going to do is subtract the X terms of H and I, so that's negative 2 and 22. So I'm going to have negative 2 minus 22, that quantity squared, plus, and then I'm going to do the same with the Y term, so 1 and 1. So it's 1 minus 1, that quantity squared. And so I just simplify this out. Negative 2 minus 22 is negative 24 squared, plus 1 minus 1 is 0. And so here, the square root of negative 124 squared is what we're left with, because here 0 squared is 0, and you add anything to 0 and it's just itself. So negative 24 squared is 576. And then the square root of that is positive 24. So the length of HI is 24. So that's one length of this triangle. So then we have to go over here and calculate another length. So we're going to look at IJ. And so I'm going to, the x coordinates of I and j are 22 and 10. So I'm going to go ahead and subtract those. 22 minus 10, quantity squared. And then the y coordinates of I and j are 1 and negative 4. So I'm going to subtract those. 1 minus negative 4, quantity squared. Then I go ahead and do that subtraction. And 22 minus 10 is 12 squared, plus then 1 minus negative 4 is 5 squared. And then that's going to equal 12 squared is 144, 5 squared is 25, so 144 plus 25, and that's 169. So then I have the square root of 169, which is 13. So I have one side that's 24 units long and another side that's 13 units long. So the last thing I have to do is calculate what is the length of J to H. So I'm going to go ahead and do that. The x coordinates of J and H, I mean, you can write it either way. You have 10 minus a negative 2. Just remember you have to be consistent. So since I'm starting with J in the first one, I have to start with J with my y's also. That quantity squared plus, and then my y coordinates here are negative 4 and 1. So I'm going to have negative 4 minus 1, that quantity squared. So 10 minus a negative 2 is 12. And then negative 4 minus 1 is negative 5. Both of those numbers are being squared. 12 squared is 144. Negative 5 squared is 25. You add those together and that gives you the square root of 169, which is 13. So then I end up with, I have two sides of 13 and one's 24. So I have two sides that are congruent and another one that's different. That's what an isosceles triangle is. And so C is my answer because that's the only one that says isosceles. The other type of question you could see are these ones dealing with transformation. So what the ones to know is if you take this trapezoid and move it here, how would you describe that transformation? How do you describe moving this Q to this Q, this T to this T, this S to this S, this R to this R? So I'm going to go ahead and look at the actual coordinates of Q, which regular Q is negative 5, 6. And the new Q is 5, negative 3. So if I look at the x coordinates here, I have a negative 5 and then a positive 5. So those are just opposites. So I'm just taking the opposite of the x coordinate to move it. And then if I look at the y's, I'm going from 6 to negative 3. I went down 9. I subtracted 9. So the one here that shows that you're taking the opposite of x, so positive x to negative x, that's the same as saying you're taking opposite, and subtracting 9 is letter D, my answer. This question reads, what are the coordinates of the new point Q if the new figure QRST is a 270 clockwise rotation of the figure QRST of the origin? So if I'm going 270 degrees rotation, 90 degrees is going to put me in the fourth quadrant. 180 degrees is going to put me in the third quadrant. and 270 is going to put me in the second quadrant. So I'm going to go ahead and look which of these points actually is in the second quadrant. So the second quadrant has a negative x and a positive y. The only answer here that has a negative x and a positive y is A. So A is my answer. This next problem reads, if the figure QRST is reflected across the y-axis and translated 5 units down, which of the following would be the coordinates for point T, the new point T? So reflected over the y-axis means that if you fold it along the y-axis, and then, like if you were to put ink on this and then fold it along the y-axis and press it down, that ink that's left over here would be your new quadrilateral. So one way to do that is it's a reflection. So the T here is 4 units away from the y-axis. So that means the new T is going to be 4 units away from the y-axis in the other direction. So right there. But not only is it reflected, it's also translated 5 units down. So if I count down 5, 1, 2, 3, 4, 5, that's going to put my new T right here. And so the coordinates there is 4, -4, which is answer C. So what is the rule for the transformation formed by a translation 5 units to the left and 8 units down? So if you think about your x and y axis, you have your y-axis is your vertical and your x-axis is your horizontal. So the left and right, that's going to be along the x-axis. So if you're going 5 units to the left, you're going more negative. You're going down. So it's going to be a subtract 5. So you need to subtract 5 on your x. So that rules out C and D. And then your 8 units down, that's going to be along the y. So if you're going down, once again, you're getting more negative. So that's also going to be a subtraction. So your answer here is going to be letter A, because it has the subtraction on the y. All right, so here it wants to know the rule. And so I'm looking at my answers, and it looks like it's opposite. So if I'm going to take the x, take the opposite of it, but keep the same y. That's what A says. B says that I'm going to switch them. And C says I keep the x, take the opposite of y. And D says I take the opposite of both of them. So I'm going to go ahead and look at 2 points. I'm just going to pick any 2 so I can see if I can come up with a pattern. So this top corner here is -6, 3. And this top corner on the other side is 2, 3. So those numbers, there must be a reflection going on because those numbers are they're different. The -6 and the 2, they're not just opposites and it's not flipped. So I'm going to want to pick that other corner to see if that helps me out at all. And so I have -2, 3. And then I have 6, 3. So if I look at these 2 points right here, they have the same y, but I have a -6 and a +6. So a negative and positive version of the same answer. And then if I look at these 2 points here, I have the same y again, but the x's are opposites. I have -2 and +2. So they are opposites again. So that's the pattern where I have the same y but opposite x's. Letter A is the answer that shows me that rule. So I'm so glad that you joined us today, and I hope you learned something new.